Hello students, we are dealing the chapter ray optics. In my previous class I told you regarding the ray diagram for convex lens. Now we will see the ray diagram for concave lens. Here a concave lens has been drawn. It has two surfaces, surface 1 and surface 2. Object is placed beyond C. The beam arises from O. It strikes at the first surface whose radius is R1. At the point P where it strikes, it bends towards the normal because it entering into the denser medium. According to the law of refraction, it should bend towards the normal. So, the beam bends towards the normal and it will move like this. Now, after moving certain distance, it faces another surface from which the beam has to come out in the rarer medium. So, when it comes out in the rarer medium, it bends away from the normal, which is shown by ray X. On producing this ray X, it forms image at point I that lies between center and pole. So, now we will try to understand the ray diagram using this concept. Here parallel beams are coming from infinity. Here the object is placed at infinity, therefore parallel beams are coming from infinity. This will enter into the concave lens and it will diverges. So, this diverging rays when produces on the backward, it will meet at a point called focus point. So, here we are getting virtual focus, that is why its focus is negative. So, for concave lens, image is virtual. Now, we will see the second case when the object is placed beyond C. The parallel beam comes from the object AB, strikes at the lens and it will also diverges and it will move in this way as shown here. On producing on the backward, it will meet at a point F, which is focus point. Another beam which passes through the pole, these two beams coincides at a point and here we will get an image I dash as well as B dash, which is virtual again. Now, let us see what will happen when the object is placed between center and focus. Here we have object AB. Again in a similar manner, the parallel beams comes from point A, it strikes on the concave lens which diverges the beam. So, this diverging beam meets at a focus point. Another beam which passes through the pole will also meets at point say X, and let this on combining the X as well as D, we get an image. So, in all these cases we are seeing that the image lies between focus and pole irrespective of the location of the object. Whether you place the object at C, whether you place the object beyond C, or whether it is placed between C and F or between F and P, image will always obtain between focus and pole. Now, we will see the ray diagram or thin lens formula for convex lens. Here a ray diagram has been drawn. The object is placed beyond C, AB is an object, parallel beam arises from various points of the object, falls on the convex lens, its property is to converge, accordingly it will converges, and after conversion the parallel beam passes through the focus point which is named as X. Another beam moves through the pole which is shown by AO A dash. These two beams meet at a point A dash and you will get an inverted image on the other side. Now, we will try to derive the lens formula for this case. For that purpose, we can take the triangle ABO, take the triangles ABO and OB dash A dash. Here angle B equal to angle B dash is equal to 90 degree, another is AOB equal to B dash O A dash, vertically opposite angles. So, these two triangles are similar by AA similarity rule. So, we can write ABO similar to A dash B dash O. So, if two triangles are similar, then we can say their corresponding parts are, the ratios of their corresponding parts are equal, that is AB by B dash A dash is equal to BO by OB dash. Let this as equation 1. Now take the triangle POX and XB dash A dash. In these triangles, that is POX and XB dash A dash. Here PXO is equal to BX B dash X A dash, vertically opposite angles, and POX is equal to X B dash A dash equal to 90 degree. So these two triangles also similar by AA similarity rule, hence so their corresponding, the ratios of their corresponding parts are also has to be equal, that is PO by B dash A dash will be equal to OX divided by X B dash. Now PO and AB both are same because they are the perpendicular distance between two parallel lines, hence in place of PO we can write AB. Replacing PO by AB in equation 2, we get AB by B dash A dash is equal to OX by X B dash, equation 3. Now comparing equation 1 and 3 gives VO divided by OB dash is equal to OX divided by XB dash. Now OX is F, BO is U, that is object distance, and OB dash is image distance V, and then XB dash can be replaced with OB dash minus OX. So replacing XB dash gives BO by OB dash is equal to OX divided by XB dash is equal to OB dash minus OX. Now from the figure, BO is U, so we can replace it with U, divided by OB dash is V, and then OX is F divided by OB dash is V minus OX is again F. Let this is equation 4. Now reversing this equation gives V minus F divided by F is equal to V by U. Now after simplification it gives V by F minus F by F is equal to V by U, or V by F minus 1 is equal to V by U, equation 5. Dividing this equation with V gives 1 by F minus 1 by V is equal to 1 by U, or bring this 1 by V towards that side, we get 1 by U plus 1 by V is equal to 1 by F. Now after this we have to use sign convention. Here for sign convention we have to take the concept of Cartesian coordinate system. Towards left side U is located, that is why U is to be taken as negative, V is lying right side of the origin, that is why it should be taken as a positive, and F is also positive because it lies towards positive direction. So replacing U with minus U gives 1 by minus U plus 1 by V is equal to 1 by F, or we can say 1 by F is equal to 1 by V minus 1 by U, or 1 by V minus 1 by U, 1 by V minus 1 by U is equal to 1 by F. This equation is called thin lens formula. Now we will apply the conditions. Here the derived formula is 1 by V minus 1 by U equal to 1 by F, which is called thin lens formula. Now we are applying the condition. What will happen if image forms at infinity? When image forms at infinity, putting the value of V is equal to infinite in the given equation, we get 1 by F is equal to 1 by U, or simply we get F is equal to U, which is said to be as first principal focal point. Second, if the object is located at infinity and image forms at focus point, then that point is said to be a second principal focal point. Now we will try to derive the thin lens formula for concave lens. Here a concave lens is there. An object is placed beyond C, AB, parallel beam arises from the object and it will strikes at the lens and it diverges. So on producing this diverged beam on the backward, it will meet at focus point X. Another beam passes through the pole O. So, both the rays meeting at a point A dash, which forms a image which is a virtual. Now, we will try to derive the relation for it. Take the triangle A, B, O and A dash, B dash, O. In triangle A, B, O and A dash, B dash, O. Angle B is equal to angle B dash, or that is A, B dash, O is equal to 90 degree, and then angle AOB is equal to A dash, B dash, sorry, AOB dash common. So, these two triangles are similar now. If the two triangles are similar, then the ratios of their corresponding sides are equal, that is AB divided by A dash, B dash is equal to BO divided by B dash O. Let this as equation 1. Now, similarly, take the triangle X A dash, B dash and X P O. So, in triangles X A dash, B dash and X P O, we have A dash X B dash is equal to P X O common, and X B dash A dash is equal to X O P, both are 90 degree. So, these two triangles are also similar. If the two triangles are similar, then their corresponding ratios of their corresponding sides are also has to be equal, that is PO divided by A dash, B dash will be equal to XO divided by X B dash. Now, AB as well as PO are the perpendicular line segments between two parallel lines. So, PO is equal to AB, that is PO is equal to AB. So, in place of PO we can write AB. So, replacing PO with AB gives AB divided by A dash, B dash is equal to XO divided by X B dash. So, let this as equation 2. Comparing equation 1 and 2, the left sides are equal, therefore, right sides are also has to be equal. So, we get BO divided by B dash O is equal to XO divided by X B dash. From the figure, X B dash is equal to XO minus B dash O. So, XO, X B dash can be written as XO divided by X B dash is equal to XO minus B dash O. So, X B dash is equal to XO minus B dash O. Now, on seeing this equation, we find that BO is nothing but it is object distance, B dash O is image distance, XO is focal length. So, replacing that with their given assigned letters, we get BO in place of BO as U and in place of B dash O as V is equal to XO is nothing but it is F divided by XO, again it is F minus B dash O is V. Let this as equation 3. Reverse this equation, we get F minus V divided by F is equal to V by U. Now, separating this F on both the letters, we get F by F minus V by F is equal to V by U. So, it gives 1 minus V by F is equal to V by U. Divide both sides with V gives 1 by V minus 1 by F is equal to 1 by U. Bring this 1 by F towards right side and bring 1 by U towards left side. Doing that, we get 1 by V minus 1 by U is equal to 1 by F. Now, we have to use the sign convention. Here U is negative, U is negative, V is also negative, F is also negative. Using sign convention, we get 1 by minus V minus 1 by minus U is equal to minus 1 by F. Now, minus presents on right hand side as well as the left hand side. So, it can be cancelled. After cancellation, we get 1 by V minus 1 by U is equal to 1 by F. We find that both for convex lens as well as concave lens, the thin lens formula is same. Now we will see the refraction through spherical surfaces. Here a convex spherical surface has been taken whose refractive index is mu2. Object is placed in the rarer medium whose refractive index is mu1, and the rays which arises from the object O strikes at the refracting surface. Here it will enter into the second medium which is denser. Because of the denseness, it will bend towards the normal. The radius of the convex surface is acting as a normal, so it will bend towards the normal, making an angle of refraction r with the normal, and finally image will form in the denser medium at point I. Let alpha be the angle of inclination that made by the beam which arises from the object with the principal axis, and beta be the angle of inclination by the radius with the principal axis, and theta be the angle made by a refracted beam with the normal. Now we will try to find out the value of I in terms of alpha, beta and theta, similarly or r also. Now see the triangle OPC. In triangle OPC, I is acting as an exterior angle which is equal to sum of interior opposite angle. So I is equal to alpha plus beta. Exterior angle is equal to sum of interior opposite angles. Now similarly in triangle PCI, the exterior angle beta will be equal to r plus theta. Beta is equal to r plus theta, or r is equal to beta minus theta. Now from triangle OPQ, tan alpha is equal to PQ divided by OQ. If angles are very small, then tan alpha can be written as alpha is equal to PQ divided by OQ. PQ is nothing but it is height, h I am taking it, let it as h, divided by OQ is object distance, I am naming it as u. Here we are taking the refraction through convex surfaces. O is the object which arises from the principal axis. The ray which strikes at the convex surfaces bends towards the normal and image forms in the denser medium. Now from the triangular property, exterior angle is equal to sum of interior opposite angles, therefore I is equal to alpha plus beta. Now from the triangle, tan alpha is equal to h divided by u. For small angle, tan alpha can be written as alpha, therefore alpha is equal to h by u, plus similarly beta is equal to h divided by r, which gives I is equal to h by u plus h by r. Now similarly from triangle PCQ, in this triangle we get angle beta, the exterior angle is equal to sum of interior opposite angles, that is r plus theta. So in triangle PCI, the exterior angle beta will be equal to r plus theta. So we get beta is equal to r plus theta, from which we are getting r is equal to beta minus theta. Now similarly the value of a beta for small angle is given by h by r, which is substituted here. Theta is h divided by v. So taking the ratios, I by r gives h by u plus h by r divided by h by r minus h by v. So we know that I by r is nothing but it is mu according to Snell's law for small angle. So for I by r we can put mu, which is equal to h divided by 1 by u plus 1 by r divided by h 1 by r minus 1 by v. H get cancelled out, finally we get mu is equal to 1 by u plus 1 by r divided by 1 by r minus 1 by v. And the value of mu is nothing but it is mu2 by mu1. Substituting that gives mu2 by mu1 is equal to 1 by u plus 1 by r divided by 1 by r minus 1 by v. Cross multiplication gives mu2 multiplied by 1 by r minus 1 by v is equal to mu1 multiplied by 1 by u plus 1 by r. Now this gives mu2 multiplied by 1 by r is mu2 by r minus mu2 by v is equal to mu1 by u plus mu1 by r. Now bring this mu1 by u towards this side and take this mu2 by r towards the right side. Doing that gives minus mu 1 divided by u minus mu 2 by v is equal to mu 1 by r minus mu 2 by r. So, cancellation minus sign on both the sides gives mu 2 by v plus mu 1 by u is equal to mu 2 minus mu 1 by r. Now, from the figure u is negative, v and f both are v and r both are positive, therefore, putting the sign for u as minus u gives mu 2 by v minus mu 1 by u is equal to mu 2 by mu 1 by r. This is the relation that makes between v, u, r and refractive indices. The derived equation is mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 divided by r. Here we are taking another situation when the object lies in the denser medium and the image forms in rarer medium. That is, the refractive indices has to be changed in that equation to get the equation for the condition when the object is placed in denser medium and image forms in rarer medium. So, mu 2 is to be replaced with mu 1 and mu 1 is to be replaced with mu 2 in the given equation, and finally we get mu 1 by v minus mu 2 by u is equal to mu 1 minus mu 2 by r. So, this equation is used when the object lies in denser medium, and that equation is used when the object lies in rarer medium, image forms in denser medium. Now, we will see the refraction through concave lens. Here object is placed in the rarer medium and image forms in the denser medium. Beam of ray arises from the object, it strikes at the surface at point P, making angle of incidence with the normal Cp. When it enters into denser medium, it bends towards the normal, making an angle of refraction r with the normal. So, it is diverging, therefore, on producing this beam, it will form image in the rarer medium as virtual image. Now, we will try to find out the relation between u, v, r and refractive indices. So, here CD is nothing but it is r, this is v and this one is u. So, here OD is equal to u, ID is equal to v, CD is equal to r. Now, from the figure OPC, in triangle OPC we have alpha plus triangle OPC, we have alpha plus I is equal to theta or I is equal to theta minus alpha. Let this as equation 1, and in triangle IPC we have beta plus r is equal to theta. In triangle IPC we get r plus beta is equal to theta or r is equal to theta minus beta, equation 2. So, we are doing all these things in order to find out the value of I and value of r. After that we will use the Snell's law because refraction is taking place. Now, from the triangle OPD, in triangle OPD we have tan alpha is equal to PD by OD, PD is equal to H and OD is equal to U. Similarly, if the angles are small, then tan alpha can be written as alpha. So, alpha is equal to H by U. Similarly, beta is equal to H by V, and then theta is equal to H by R. Substituting all these values in equation 2 gives I is equal to, in place of theta we have H by R, minus in place of alpha we have H by U. Similarly, R is equal to, in place of theta again we have H by R, and then minus value of beta is H by V. Now, taking the ratio gives I by R is equal to H by R minus H by U divided by H by R minus H by V. H can be cancelled on both numerator and denominator. Finally, we get I by R is equal to 1 by r minus 1 by u divided by 1 by r minus 1 by v. So, I by r can be taken as the refractive index, mu 2 by mu 1, this will be equal to 1 by r minus 1 by u divided by 1 by r minus 1 by v. Cross multiplication gives mu 2 multiplied by 1 by r minus 1 by v is equal to mu 1 multiplied by 1 by r minus 1 by u. So, on multiplication with mu 2 and mu 1 on both sides, it gives mu 2 by r minus mu 2 by v is equal to mu 1 by r minus mu 1 by u. Take r terms towards that side and bring mu 1 by u towards left hand side. We get mu 1 by u minus mu 2 by v is equal to mu 1 by r minus mu 2 by r. Now, multiplication with negative sign on both sides gives mu 2 by v minus mu by u is equal to mu 2 minus mu 1 by r. Now, we have to use the sign convention. Here for sign convention we have u is equal to negative, v is also negative, r is also negative. So, substituting negative values on the respective places for v, u and r, the equation do not change and it will remain as mu 2 by v minus mu 1 by u is equal to mu 2 minus mu 1 by r. So, this is the relation between refractive indices v, u and r for concave lens. We see that whether the lens is convex or concave, the equation or the expression mu 2 by v minus mu 1 by v, mu 1 by u is equal to mu 2 minus mu 1 by u, mu 1 by r are equally applicable. Now, we will see the situation when the object is placed in denser medium. When object is placed in denser medium, we have to just interchange the refractive indices. On interchanging the refractive indices, we get mu 1 by v minus mu 2 by u is equal to mu 2 minus mu 1 by r. So, this is the expressions we calculated for both convex as well as concave lenses. Now, we will try to derive the lens maker formula. Here the object is placed in rarer medium mu 1 and image is also forming in the rarer medium, and we have lens whose refractive index is mu 2, which is denser medium. For first surface, object appears to be in rarer medium and image forms in the denser medium at point I dash, which is at a distance of v dash from the lens. So, for first surface, the expression that connects refractive index v, u and r is given by mu 2 by v dash minus mu 1 by u is equal to mu 2 minus mu 1 divided by r1, where r1 is the radius of first surface. Similarly, for second surface, the image formed by the first surface is acting as an virtual object for the second surface. Therefore, for second surface, object is v dash. So, and the refractive index here in the medium where the object is there is mu 2. So, for second surface, the expression becomes mu 1 by v minus mu 2 by v dash is equal to mu 1 minus mu 2 by r2. Adding these two equation gives mu 2 by v dash minus mu 1 by u plus mu 1 minus mu 1 by v minus mu 2 by v dash is equal to mu 1 minus mu 2 by r2 plus mu 2 minus mu 1 divided by r1. Here mu 2 by v dash minus mu 2 by v dash cancel out, and finally we get mu 1 by v minus mu 1 by u is equal to, on the right hand side we have mu 2 minus mu 1 divided by r1. Minus is taken as common from this mu 1 minus mu 2, which gives mu 2 minus mu 1 divided by r2. After that, we can take mu 2 minus mu 1 as the common factor. Taking common factor as mu 2 minus mu 1 gives bracket 1 by r1 minus 1 by r2 multiplied by mu 2 minus mu 1. Then mu 1 is taken common from the left hand side also, and this mu 1 brought in the denominator. After that, we get 1 by v minus 1 by u is equal to mu 2 minus mu 1 divided by mu 1. If the object is placed in rarer medium, which is assumed to be as air medium or free space, then mu 1 will be equal to 1. Substituting the value of mu 1 is equal to 1. This expression gives 1 by v minus 1 by u is equal to mu 2 minus mu 1 multiplied by 1 by r1 minus 1 by r2. Now from thin lens formula, we know that 1 by V minus 1 by U is equal to 1 by F. So in place of 1 by V minus 1 by F, we can replace it with 1 by F. So final expression for this is 1 by F is equal to mu 2 minus 1 bracket 1 by R1 minus 1 by R2. So mu 2 can be written as mu, and the expression becomes 1 by F is equal to mu minus 1 by R1 minus 1 by R2. This equation is called lens maker formula, which is used to carve out the lens to introduce the required curvature by curving it out according to the requirement for the focal length. R1 and R2 can be changed. So these are the few topics which we tried to understand on this class, and we will do the remaining topics in our next class. Till then, I hope that all of you will practice, do your level best. Thank you.